Hi everybody, welcome back to videos. This is Unit 6, I believe it's Lesson 5. And what I'd like to do, even though we went through Section 7 of this unit together in class, I just wanted to review it again on video so that those of you that were not here or those of you that need a little bit of refresher, you can always turn back to the video. So in this section, we are drawing the dot diagrams for covalent things. These are all covalent molecules, right? They have covalent bonds. They're two or more nonmetals bonded together, right? And when you're drawing covalent structures, you need to show the sharing of electrons. And so on the previous page, I walk you through all the steps that I'm going to be using here, steps 1 through 5, in order to draw these structures. So recognize that you have all these steps here. I'm going to walk you through them with just a couple of these structures. I believe I'll do B, C, and D here, okay? Because I think we did A in class together. So the first step when you draw these is valence electrons. You want to write down how many valence electrons each element has and then add them together. Remember, valence electrons are the last number in the electron configuration. They're the number of electrons in the outermost energy level of an element. So hydrogen, if you look up its configuration on the periodic table under the atomic number, it has 1 valence electron. And chlorine has 7 valence electrons. So the total valence electrons in your molecule is 8. That's an important number because that's how many dots you must have in your picture, okay? The second step is happiness. And remember, everybody's happy with 8 in their outer shell that you'll be drawing, except for hydrogen. Hydrogen is happy with 2 in its outer shell. So hydrogen will have 2 when it's happy, and chlorine will have 8 when it's happy, for a total of 10 for happiness. The third step is to subtract these. So you take happiness minus valence electrons, and then you divide that number by 2. And that number is important because that tells you the number of bonds you will need to have in your molecule, or the number of shared pairs of electrons. So we're going to need 1 bond in our molecule. Now, there's only 2 elements here, so there is no center. Okay, so we're back. Sorry about that. Since there is no, there's only 2 atoms, you will just draw them next to each other. Remember, a bond is a pair of electrons. That's what a bond is. So if we have 1 bond, we're sharing 1 pair of electrons. You place the shared electrons in between the 2 symbols. That represents the bond. If you would like to use a line for a bond, that's fine as well. Just remember that a line counts as 2 electrons. After you do that, your final step is to fill in so that everybody's happy. Now, hydrogen is supposed to have 2 electrons attached to it for happiness. Oops, I made a dot on my paper that looks like an electron. So that's 2. It's already happy. Chlorine has to have 8. It only has 2. So it needs 3, 4, 5, 6, 7, 8. And if you count the dots in this picture, there are 8, just like we're supposed to have. You do the same thing if you're doing the lines. Hydrogen, remember, a line is 2, H has 2, Cl has 2, so you need 3, 4, 5, 6, 7, 8. So that is your dot diagram. One of these 2, you don't have to do both. Either this or this are acceptable. Okay? I'll go a little bit faster. SiF4. We have Si has 4 valence electrons, and there are 4 fluorines that each have 7. So that's 4 plus 28, which gives us a total of 32 valence electrons. A lot more dots in this picture. We're going to need 32 dots in our picture. Happiness is 8 for both of these guys, so Si is happy with 8. And you have 4 fluorines that are each happy with 8. So that's 8 plus 32, which gives you a total of 40 for happiness. Excuse me, for happiness. We subtract divide by 2, and this time we wind up with 4 bonds. So we're going to need 4 shared pairs in this molecule. The element that there is less atoms of, that has the least subscript, which is Si, goes in the middle, and you place the 4 fluorines around it. Pretend it's in a box, right? An imaginary box. Place the 4 fluorines around it. We need 4 bonds, so we'll do 1 bond between each fluorine and Si. There's 1 bond, 2 bonds, 3 bonds, 4 bonds. All set with our bonds. Now we fill in so that everybody's happy. F is happy with 8, so each F will need 6 more electrons. And you go work outside to inside. So all our F's are done. SI's happy with 8, and as you can tell, it already has 8 dots around it, so everybody's happy. And if you count the total dots in that picture, there are 32. Again, if you're doing lines, it looks like this, right? 4 bonds, and then each F should have 6 dots. Make sure your dots look like dots, again, and not that you just sneezed on your paper. Okay, and finally, we run into carbon dioxide here. Carbon has 4 valence electrons, and each oxygen has 6. So that's 12 and 4, which gives you 16 valence electrons. Carbon's happy with 8, as is oxygen. So that's 16 and 8, which gives you 24. 24 minus 16 gives you 8, divided by 2 is 4 bonds. So you put the element that there's less atoms of, that has the lower subscript in the middle, and then you put the other elements around it. Now, we need to share 4 pairs of electrons. So we do 1 pair there and 1 pair there. But we still need to share 2 more. So this is going to be what's called a double bond. You don't add on more oxygens because according to the formula, you're only allowed to have 2. You instead make another pair be shared here between this carbon and this oxygen, and another pair be shared here between that carbon and that oxygen. If you're doing lines, it might look something like that. That's a double bond. If you're sharing 2 pairs of electrons, that's a double bond. Okay? So there's your 4 bonds. And now you would fill in so that everybody has 8. Everybody's happy. So this oxygen up here has 1, 2, 3, 4. So it needs only 4 more. This oxygen has 1, 2, 3, 4. So it only needs 4 more. And the carbon already has 1, 2, 3, 4, 5, 6, 7, 8. Remember, electrons in the space between the symbols get counted towards both elements. So now everybody's happy. And if you count the electrons, we have 16. Okay? So it absolutely, and again, if you're doing the lines, it looks like this. Okay? It absolutely must have the double bond between the carbons. Students go wrong because they try to put single bonds. Okay? So I wanted to just get that on video so that if you had problems, you had somewhere else to turn. If you did not do these in your notes yet, make sure you do them in your notes while watching the video. We've already completed section 8 here, so I just want to kind of summarize what we did in our demonstration yesterday and some of the properties of nonmetals and metals and ionic compounds and molecular substances. So melting point. Nonmetals have very low melting points. They have very low boiling points. When I say nonmetals, I mean elemental nonmetals, not nonmetals in compounds. Because when you're in a compound, your properties change. Nonmetals never conduct electricity. They're not shiny. Again, this is reviewed from a previous unit, and they're brittle. They're not malleable and ductile. Okay? Metals have high melting and boiling points. They are unique because they can conduct as solids, right? They also conduct when melted, but since they have high melting points, it's hard to melt them. The reason they conduct, remember, is they have the mobile valence electrons that move about and carry the electric current. Metals do have luster, and they are malleable and ductile. And again, when I talk about a metal, I'm talking about an elemental metal, something with a metallic bond. Ionic compounds, like you saw in the demonstration, we could not melt the salt. That's your typical ionic compound. There's your NaCl. They have high melting points. They have high boiling points. They can conduct, but they can't conduct as solids. They conduct as liquids, which is hard to do, again, because they have such high melting points, or when dissolved in water, so that we can break apart that crystalline structure of ions. They are not shiny, and they are not malleable and ductile. And finally, covalent compounds like sugar. That was the one that we tested. These are non-metal compounds, remember? They have low melting points. Remember, another covalent compound is water. We were able to melt the ice, the solid water. We were able to melt the sugar in class. They have low boiling points. They never conduct in any phase. They don't have moving charged particles. And that's what you need to be able to conduct electricity. They are not shiny, and they are not malleable and ductile. And so what we can use this information for, now that we have it, is if we have an unknown substance, we can perform tests in order to determine what kind of bonds it has, or maybe what kind of substance it is. That's it for tonight, everybody. Have a great night. Bye-bye.